think, okay, this one is one of the ones that you sent. So let's go through. This is additive property of equality with fractions and mixed numbers. And it's probably the mixed numbers that are bothering you.
Yeah, it's the whole number.
Yeah.
And then, which I started finally kind of getting it, but then I had made too many wrong errors, and then it will just revisit this later.
It does, yeah. Okay. And then, let's see, with fractions and mixed numbers. So if you are putting this in a section of your pie, it's going to be in that section that is linear equations and inequalities. If you're doing it in your notebook into sections, which I think is the best way to do it. Okay, so it's in that dark purple. First one is, I am recording and I'm going to post this for everybody because you're not the only person. I mean, you're the only person that's been asking, but I know that you're not the only person that doesn't understand it. You know what I mean? No one else, no one's sent it. So I am going to post this after we get done. Okay, so in the video that I sent out that didn't have the voice to it, I talked about how this problem could be done in two ways. So I'm going to write the problem down twice, and I'm going to demonstrate either way, okay? So if you're solving it like you solve a regular equation, you know your job is to get the W by itself, okay? So that's the same step. And then in order to do that, you see that you have an add 2/3, and so you want to subtract 2/3 from both sides. And I think that was pretty self-explanatory in the explanation part, but I think that it was this next step that was bothersome. Okay, so for right here, I know that I'm supposed to subtract the 2/3 from both sides, and then I take 6 1/4 minus 2/3. Well, if I just look at the fractional part, 2/3 is bigger than 1/4, so I can't take 2/3 away from 1/4. So what I'm going to have to do is I'm going to have to borrow, and that's the part that you're not, like it's not clear in the explanation. You're borrowing 1 from the 6, like when you did subtraction a long time ago in elementary school, when you had to borrow. Okay, so I'm borrowing 1 from the 6, and that's going to turn the 6 into a 5. Okay? But the one that I borrow from a 6, I mean, it's a 1, okay? So this is like 5 plus 1, okay? The 1 that I'm borrowing from the 6, I have to make it into a fraction that I can put together with this fraction. And so it has to be equivalent to 1, but it's got to be able to combine with 1/4. So a fraction that is equivalent to 1 that also combines with 1/4, we would call that 4/4. So I have 5 4/4 and 1/4. So that makes this 5 5/4. And that's where they were getting that 5 5/4 from. And so now you can subtract the 2/3. So you still have to find a common denominator. And the common denominator here would be 12. And so this next step in the problem is the same. I need my denominator to go from 4 to 12, so I had to multiply times 3. So I would multiply the numerator times 3. I need my denominator here to go from 3 to 12, so I had to multiply times 4. So my new numerator would be 2 times 4, which is 8. So now I have 5 15/12 minus 8/12. And so I can subtract. So I get 5, my denominator is common, 12ths, and 15 minus 8 is 7. So the final answer is 5 7/12.
Got it.
Okay, so that's one way. Now I'd like to show you a different way. Almost everybody can remember or does remember how to take a mixed number that means a whole number with a fraction, and convert it to an improper. Okay, because y'all got really good at that when y'all were younger. So what you do is you multiply 6 times 4, and then you add the 1. So that's 24 plus 1, which is 25, and the denominator stays the same. So 6 1/4 is equivalent to 25 over 4. Okay? You multiply 4 times 6, 24, plus 1, 25. And that's how I get the new numerator. So what I'm going to do now is I'm going to work this problem this way instead. And this will help me so that I don't have to borrow like I did over here. So what I'll do now is I'm going to use that technique that makes my life so much easier if I just get rid of the fractions. And what I do is I take my equation and I multiply by the least common denominator. Since I have a denominator of 3 and a denominator of 4, I'm looking for the number that 3 and 4 both go into. And that number is 12. They go into a lot of numbers, but you want the smallest one, 12. Okay? So now I'm going to take this 12 and I'm going to multiply all the pieces of my equation by the 12. So I'm going to multiply 12 times the W plus 12 times the 2/3 equals 12 times the 25/4. And this technique is the technique that you should be using when your equations have fractions in them. So now I come back over here and 12 times W is just 12W. When I multiply 12 times 2/3, that's 12 over 1. So I'm multiplying 12 over 1 times 2 over 3. Well, I know that my job was to get a number that 3 goes into, and 3 goes into 12. That's why I use 12. So 3 goes into 12 4 times. So now I have 4 times 2, which is 8. So positive 8 or plus 8, no more fraction. And the same thing is going to happen down here. This is 12 over 1. I'm multiplying 12 over 1 times 25 over 4. I pick 12 because 4 goes into 12. And 4 goes into 12 3 times. And so now I have 3 times 25, which is 75. And so now I've got this equation that doesn't have fractions in it anymore, and I can just solve it like normal. So just like in the steps before, I'm trying to get the W by itself. I see a multiply by 12, and I see an add 8. I'm going to undo the add 8 first. I undo an add 8 with a subtract 8. So I'll subtract 8 from both sides. The 8 subtract out. So that gives me 12W is equal to 75 minus 8, which is 67. And now I have to undo my multiply by 12. To undo a multiply by 12, I use a divide by 12. So I'll divide both sides by 12. The 12s divide out. So I get W is equal to 67 over 12. And I can leave it just like that. I do have to simplify. You know, if 67 had something in common with 12, I'd have to simplify, but it doesn't. 67 is prime. So this answer right here and this answer right here are the same. Now, how do you go back and forth? Well, kind of like I did a while ago, you can convert this one to double check it. 12 times 5 is 60, and 60 plus 7 is 67. So there's your 67 over 12. How do I convert 67 over 12 to 5 and 7/12? You do that with division. So you have 67 divided by 12. That's what a fraction means, divide. So 12 goes into 67 5 times. 5 times 12 is 60. Subtract. 67 minus 60 is 7. That's my remainder. So it went 5 whole times with a remainder of 7. And I had a denominator of 12. So 5 and 7/12 is the same as 67 over 12. So either method works. You can pick which one you like better. But ultimately this method right here, method 2, will be the method that you're going to use a lot in this class.